All right, welcome to IMTS Plus. I'm Fabian Alefeld. I'm the host of Additive Snack and also part of the EOS team in focusing on additive manufacturing. Today with me, I have Duann Scott, and Duann, you are such a important piece of the additive manufacturing industry. You've been in it for a long time, and you've got so many projects going on. We discussed this outside the door for a second as well. What's the latest and greatest from the great Duann?
Well, cool. Thanks for the introduction and hyperbole that I don't need to do myself now, which is great. At the moment, what I'm working on is really around education. So the core thing I'm working on is the DFAM Substack, which is about educating people on design for additive manufacturing and getting others to help educate each other, because I only know so much and there's way more expertise in the world. So it's what I'm trying to do is like bring a forum forward so people can talk about design, because there's a lot of talk in additive manufacturing about machines, materials, and process, and not so much as I think there should be about design. So that's kind of my core focus at this point in time.
That's very interesting that you say education, because I think in that case we have the same mission, which is educate not only the additive manufacturing industry, but more importantly the industry out there here at IMTS who are just getting into additive manufacturing and really trying to figure out, how do I use that technology?
Yeah, we can't just stay in the bubble and sing to the choir. We have to go out and bring in new converts. And that's the thing, is to make design for additive normal. So now there's experts who, like, as Joris Peel says, are the design wizards.
Yeah.
But we want it to just be, as you learn for injection molding, as you learn for sheet metal, as you learn for welding or whatever, or even wood fabrication, you should learn some aspects for additive, and then you can deep dive from there.
Yeah, exactly. And I'm sure you've walked the show a little bit before you came to this show.
I just got here like maybe an hour ago.
So okay, so you didn't walk the show yet.
But not enough.
What are you most excited about when you think about IMTS in the next few days that you'll experience it?
For IMTS in particular, it's the bleed, as we say, from, it's not an additive show, it's a manufacturing show. And although there is a little hallway of additive manufacturing companies where people can go and focus, they're also interdispersed throughout the whole event now. And I think that's really important to normalize it and to spread it beyond the niche, that the bubble that we live in, and get exposed to more people. And especially when it's reputable, like known names in manufacturing are doing it as well. It helps to normalize it and make it seem less risky for people who are risk adverse.
Yeah, additive manufacturing does seem like a risky endeavor when you don't really know the technologies, and there's so many different new organizations out there. And you put together a platform called the DFAM, and DFAM, by the way, stands for Design for Additive Manufacturing, the DFAM Substack. How does that help your mission to educate the existing industry, but also other industries out there?
For me, it's a way to get information out there with no gatekeepers and no filters. So I don't have to, I'm not backed by an existing company. I'm not, so I don't have to tell a narrative that helps any company in particular. It's more about what I think and what the community thinks is good to help move things forward in design and engineering. And because it's open, that means I can be a little bit more critical than I might be if I was working for a specific company.
Yeah, for sure.
And it means that people who I invite other people to write for the Substack, they're open to write whatever they want. And if I do any editing, it'll be very, very minimal, or just to give context. So I think having this platform for people to write about design is helpful. And how well it goes into broader industry, I'm not sure yet, because we've only been doing it for about 6 months. But so far, the feedback's been fairly positive.
Yeah, I really like the platform. As you said, it's unfiltered, so you get true information that is unbiased and scrapped of the marketing BS that we sometimes get in all industries, of course.
Yeah, and of course, you have to simplify a message when you're doing marketing, so it's easily digestible, and you hide some of the less fun things about the technology. So I think it's important to expose that, but then still, not make it seem so risky to scare away the risk adverse.
That is a really good point. And, risk averse people need hand holding, and they need to really understand also what the state of the art is, which in additive manufacturing especially is very difficult. The industry is moving so fast. And that also has implications on design, right? If you think about design for additive manufacturing, in the end, really 3D printing allows to unlock the creativity within engineers, within designers, within product developers. But the technology is moving so fast that these design rules that are pretty fixed in other industries are fluid, right?
Yeah.
A few years ago, we always said we had the 45-degree angle rule, right?
Yeah.
That rule doesn't exist anymore.
Yeah.
So what's the latest and greatest in design for additive manufacturing that people out there who are trying to design their first additive manufacturing part can really leverage and use?
Okay, so the first part, do something easy. Like, don't set yourself to design the most advanced heat exchanger on the planet for a high risk environment.
Yeah.
Do something simple, make a bracket.
Okay. Yeah.
Hold your phone onto your bike. Do something dumb, make a toothbrush holder. Like, do something dumb and get an easy win, just understanding what's possible, and then work your way. And then make a jig, hold something together to weld something, and like work your way towards like designing for the process and really making something real happen. And then as you get more and more comfortable with it, you can push the boundaries, and the 45-degree thing maybe doesn't matter anymore. Maybe it's 60, maybe it's 70, maybe it's 90. Maybe you can figure out a way to have some sort of heat sink to make it, an extended flat surface. I don't know.
Yeah.
But I think that it's both the industry, companies and individuals need to go through that journey. I think just jumping straight in is going to cause you a world of pain.
That is very true. And what's very dangerous actually is to jump into a project that is so complex and so difficult that you burn out. And the risk of a project failure, if you overdo it, can actually overshadow the whole additive manufacturing journey for a lot of organizations.
And it makes sense. So if you're doing it within a company, you want to impress your boss to get budget to buy the kick-ass machine. And so you push yourself as far as you can to try and make that happen. And in doing so, you risk failure, and you risk your boss, he or her, saying, you just burnt this much time and now we're back behind schedule. Machine that thing. So I think having that natural, learning curve is necessary.
That is very true. And learning curve is the perfect segue. To me, the biggest influence or the biggest tools you can pull to reduce the risk of getting into any new technology, whether it's additive manufacturing or artificial intelligence, or if you're trying to move towards digital manufacturing, is education. And you also recently joined the MIT team as a teaching assistant in their MIT X Pro program. Tell us a bit more about that, because I think that's super key to what you do and what your mission is.
Yeah, so the MIT AMX program is basically a professional workplace development tool. So it's a way for people to get an understanding of additive manufacturing in a broad sense, or to, if they already have an understanding of a certain technology, to broaden their understanding into other areas they might not know. And I did my first cohort this year only with them, and I was pretty blown away by the content, to be honest. Like, I've been studying this space for like 15 years, and I learned a lot going through all the content again. I was like, oh, wow, it's a lot to learn, but I think it's critical to have these courses, which this is a 12-week course. It runs over 12 weeks, and it's available to anybody around the world. And I think to get MIT level understanding and a basis of knowledge in 12 weeks to then help you understand where you can go deeper is amazing. Like, and it wasn't possible 5 years ago.
Yeah.
And so I think there's more and more courses like this coming together, both from educational institutions and private institutions, which I think is a good balance. And it just makes that first step way less hard, because if you don't have this opportunity to do it online through a reputable source, you have to go through all that pain and dig through marketing BS to find what's real. And this sort of, gives you a jump start on that.
Yeah, for sure. I'm a big fan of the MIT program. We've we're about to install a M100 at the MIT as well. So
cool.
we'll have some nice metal
Nice.
additive manufacturing at the MIT, and hopefully that can also then spur and give students and the faculty access to metal additive manufacturing to accelerate that growth. And hopefully also bring it into the MIT X Pro program.
There's you can learn a lot online, but there's nothing like, you know, seeing the machine and seeing the process and post-processing and depowdering and support removal. It makes you understand better, you know, what's really involved. And it's not a magic box. It can do a lot, but you need to put a lot of work to make it happen. And it's the more intelligently you design for that, the less work it is afterwards.
100%. And you know, if you talk to people who are just getting into the industry, they either have two misconceptions. The one misconception is it's a one push button technology. I design something, I press print, it's printed, done. The other misconception is additive manufacturing is not ready. It's not a manufacturing technology. It's a rapid prototyping technology. And the truth lays, you know, right in the middle, where additive manufacturing is a zero manufacturing technology. We have parts in space. We have a part on Mars today on the Perseverance rover in their MOXIE system that generates oxygen out of the Mars atmosphere. That project, super cool, right? We have parts on every rocket that goes into space. We have parts on airplanes in the automotive industry. But what's interesting is that education is that big barrier. And we talked about the MIT, and those big universities are doing a lot. But how do we get additive manufacturing closer to the actual workforce that works in manufacturing every day?
Yeah, and that's the interesting thing. If you look at the academic research that's on education for design of additive, there's a lot of happening in the postdocs and PhDs and some in the masters. And then if you look at what's happening, if you ever look on Reddit on 3D printing, it's kids doing STEM courses who have desktop 3D printers, but there's a bit of a gap in between.
Exactly.
And I think there's hope that, you know, the AM Forward program from Biden should help spur the understanding that we need to have education in the middle space for it to be able to move, like to jump across, because, you know, the leap from FDM to a DMLS machine is quite large.
That's a big leap.
So I think we do need more workplace development, and it's more broadly. I don't think it's such a big problem in Germany, but in the US, you know, manufacturing jobs were seen as inferior for a long time, and since 2000, the amount of people moving to that space and trying to get a 2-year degree or 2-year education to get into manufacturing has dropped massively. And so there needs to be a move here in the US at least to help. You know, manufacturing can be a cool job. There's some cool, you get to use cool machines, you get to make things which are substantial and change people's lives significantly. So I think there needs to be just that de-uncooling of manufacturing.
Yeah, no, and you're totally right. I mean, today we have 500,000 open jobs in the manufacturing industry. And a study that I sometimes reference is a study by Deloitte that projects that rate goes up to 2 million by 2030 open jobs in manufacturing. So we have to not only bring people into additive, but bring people into this whole manufacturing industry. And one way to do that is to showcase cool applications, as you said. It's not, you know, that boring, monotone job anymore. You get to create. Digitalization is finding its way into manufacturing, and we talk about digital manufacturing. So, you know, young kids don't only have to go into tech anymore. Manufacturing, as you said, can be cool again and can be an attraction for young talents. And what I would like to hear from you is what are some of the most impressive and inspiring applications that you've worked on, that you've seen, that can help people understand the impact that additive manufacturing can actually have?
Yeah, so the inspiring ones are the sexy space, you know, space brackets, rocket parts, combustor engines, all the wild, and, you know, Formula One cars, motorbikes, electric vehicles are all the sexy things.
Yeah.
But I think part of what's actually cooler is making normal things work better. So when most the hardware companies and software material companies do a case study. They want to show something of super high value and say we've saved millions of dollars and X performance and X better heat exchanger. But there's a bunch of things that just need to go inside of an existing machine to make it more efficient, which we can 3D print and save millions of dollars. So you can print a $35 part and make $1 million machine work a lot better.
Yeah,
I think that's kind of cool. It's like it's like punching way above your weight. If you can print a tiny little part, put it in and make something more efficient. I think that needs to be called out as being cool, as well as the sexy topology optimization, robotic generative design components as well.
I couldn't agree more. I mean, it really is. There's cool looking parts and there's impactful parts, right? One company that I think is incredible is Recarbon. Not sure if you heard about those guys, but they are working on a carbon capture and utilization system where they take the methane, the CH4 from landfills, shoot it with a plasma, add some oxygen, and turn that into carbon monoxides and hydrogen. Super impactful application. They're testing right now in Tennessee. They have already 95% uptime. One of the core parts is additively manufactured. Without additive manufacturing, that technology would not work.
Yeah, that's it. And it's like there's millions of dollars of process going into that. There's a bunch of PhDs working on it, and there's a small additive part which goes, you can make it real. It can work now because you have this complex geometry, which is only possible in this material, this process. And if you saw it on the show floor, you'd walk straight past it because you'd think, I don't know, is it some sort of filter or something? I assume it looks like, but it adds so much value. And the thing is, if we only showcase the sexy parts, then engineers won't understand that they can make these small, complex filter type devices or whatever the geometry is, which can achieve these performances, which unlock so much potential in other manufacturing processes.
Exactly. So what are some of the next events that you'll be at where you're doing exactly what we're doing right now?
Funny you ask, yeah. So at the moment I'm helping Tim Simpson at Penn State organize what may be the first design for additive manufacturing conference event / accelerator at Penn State on the 27th and 28th of September. So what I've seen being in the space for a while is that a lot of the events, sales event like IMTS Rapid, AMUG, is driven by the materials and machines companies. And it makes sense because they're paying the most money for the booths. Yeah. And so the conference sort of sways that way because you have the natural influence of commerce. And the design, the software gets put to the back a little bit and design gets put, it gets folded in small places. And so what Tim Simpson and I both came to at about the same time is we'd like to organize this 2-day intensive where people who are interested in the design process, which feeds every machine and every material, to look at what's state of the art, what's evolving new, and what can we share with others who are interested in getting deeper into that side of things. And so it's 2 days in person at Penn State. I think we have like 20 presenters from hardware, academia, software, and practitioners. Mm-hmm. No materials people. They must feel left out. But every hardware company has materials now, yeah?
Yeah.
So it's cool. Exactly. And it's really just a deep dive to get everyone, up with the latest and talking to each other, and hopefully we can do this more often.
Okay. And anybody can sign up for that?
If you got money, you can come.
Okay.
Yeah.
Okay.
I think it's $250 for the 2 days, including meals, and you'll get a cool T-shirt, limited edition.
All right.
Printed in Brooklyn.
I think we have a speaker slot, so
you do, yeah.
Maybe I'll show up as well. I want that T-shirt.
Yeah.
So you said you're always looking at the latest and greatest. What is the latest thing that you've learned about the technology, or any technology, where you're like, whoa, I didn't know that, I didn't expect that?
What I'm impressed by is the continual advance in improvement and reliability of process and materials together from the hardware and materials teams, and it's what makes me think, okay, you guys have got this hard machine material side thing, I'm going to come over here and talk about design for a while, because we have to feed those machines cool designs to make those materials worthwhile now.
Yeah.
And so the main thing I've sort of, in the last year and a half, I'm going to say, is how impressed I am with the improvement in material qualities of parts. And so that's kind of, it's I think it's been a gradual improvement, but I think it's sort of reached a high point recently. It's been impressive.
Yeah, that's a good point. The industry had a continuous maturing curve for a while, but
it's ramping.
In the past 2 years, maybe COVID helped. Who knows?
Maybe
it really shot up.
Yeah,
it really shot up.
Yeah, I'm less concerned about how a part will perform once it's designed, because there's a bunch of PhDs and very smart people working on making sure that stuff works. And now we need to help engineers understand what is possible, and then get them thinking about how to design for it.
So when you think about design, and when you think about the future that you mentioned, what's the biggest impact additive manufacturing can have to create a better future for us, for future generations, and generations after future generations?
Oh, I think if I was to simplify it, it's reduction of use of energy, efficient use of energy, because I think if we, like, the simplest thing is, like, humans use way too much energy to do everything we do. And we put ourselves in these bubbles where we have to be at 21 degrees all year round. It's insane. Like, if any other animal we saw on the planet was doing this, we'd be like, let's kill those things, because they're going to screw it up for everybody. So I think we just need to be, we need to change as how we deal with energy as humans. And I think we as engineers and designers can do our part to force that a little bit, and help things be better for when people are too lazy to make the changes they should be making for themselves.
I mean, first of all, I couldn't agree more on the air conditioning. I grew up in Germany. We don't have air conditioning. I'm not sure about Australia.
I didn't have air conditioning until I was in my late 30s.
Yeah. I mean, now I like it at night. So one thing that I've noticed too is that not only hardware is advancing very rapidly, but also software. And I think one interesting company to mention is Hyperganic, who has developed a new way of designing, at least from my perspective, a algorithmic design approach, meaning input parameters are physics models, are certain manufacturing process parameters, and they really, in a different way, aid the human creativity like I haven't seen before. What is your viewpoint on these new types of tools that from my perspective can really have an interesting impact on making the technology more accessible and creating parts that really we haven't seen ever before?
I think one of the things I find two things I find interesting about Hyperganic in particular is they're not replacing CAD. Yeah. They're replacing the design process or engineering process to affect an outcome. So you're not thinking, let's make this less bad. Let's not have lines and curves you have to do. Let's just bypass that, because CAD was based on drafting, which was based on woodwork, basically. Yeah. And welding. And then the second thing is to not build a monolithic piece of software which everybody has to buy and then use the components that they want, which is infuriating. Yeah. So for as someone who's pumped CAD, and then you've got these 9 modules you have to hide because you're never going to use them in your entire life, the fact that a company or a provider or a design collective or engineer or an app developer can use these modules to create an application to solve a set of problems and not have any of the fluff and make the UX exactly as to what's required. It's pretty cool, you know, and it's a very software first approach, and it's this concept of of software driving design. Is kind of what got me into additive in the first place, is because I was looking at app developers can make money multiple times from one app.
Yeah.
And a designer, if you're designing something, once it's made, you can only get so much money. You could design something else to make money again. And your scalability of getting in revenue from your, is this our red light? Our design is limited. But if you can design a workflow which makes objects continuously, which are customizable or not, then you can monetize that as an engineer or a software developer for physical products, which is really hard to do in other ways. And I think that's pretty cool.
That is very cool. And we now discussed new hardware, new design tools. We talked about new business models, as you said, and we talked about the impact that additive manufacturing can have on not only manufacturing but on the whole world. And yeah, we're here at IMTS Plus and also partially at the Additive Snack podcast. So in a few sentences, if you want to wrap up, what is the one additive knowledge snack that you want to give the audience out there on how to get into additive?
Okay, so if you want to get into additive, start easy, start simple, make something that's fun and kind of worthless. And then work your way up to make something that holds something, then make something that holds something of value, and then make something of value, and then design something that's high performing. Like move your way up that arc. It's like the normal crawl, walk, run thing, because the tendency is to run, fall, crawl, walk, run. So don't run first. Just take it easy, play, have fun, get addicted, go for it.
Love that. Don't run too fast and don't trip. So yeah, well, thanks, Duann. It was awesome to have you here at IMTS Plus.
Thank you for the opportunity. I appreciate it.
And if you are interested in learning more about Duann, check out DFAM Substack. And maybe even check him out at Penn State in a couple of weeks. And
if you can make your way to City College, I don't even know.
Not sure.
Penn State. In the next couple of weeks, 27th to 28th of September. And if not, you want to learn more about additive online, check out MIT's AMX course. It runs many times a year and is full of like really useful content to get started.
Awesome. Thanks so much.